In my childhood, I have played with this toy a lot. Basically, there's this doll. If you open this, you'll find another doll. Opening that, you'll find another one inside. Well, you too might have come across this toy or might have played with this toy. And if you haven't, let's take a look. So what you see is that all these dolls actually look exactly the same as the other. The only difference is the size. So the difference is only in the size, and in geometry we use the term similar to show that the only difference is the difference in size and the shape is exactly the same. Also we know that if you go to a photographer, then from the same negative, a photographer can give you a photograph of any size. So be it a passport size photo or a stamp size photo, what you see is that the photo is exactly the same. What has changed is just the size of the image. So these two again can be said to be similar because the only difference is difference in size. So far we've studied about congruent images, which means that they have exactly the same shape and the size. And we use this symbol to represent congruent. This two lines at the bottom show same size, whereas this inverted S shows same shape. So this was congruent. Now what we'll study is similar. So similar means same shape, not necessarily the same size. And since same shape is indicated by an inverted S, what we get is just an inverted S. So these two images here, you can see, are same in shape, but the difference is the size, and hence I can say that they are similar. Now let us try to apply this in geometry. So we have these different similar figures. Similar figures, only difference is difference in size. Look at these line segments here. All look exactly of the same shape. Only difference is difference in size. Now the square is also of the same shape. The difference is the size. So only the side is changing, and hence the shape of this shape is not changing. Only the size is changing with the change in the side. Again, different circles are also can be said to be similar because what is changing is just the radius. The shape is not changing. All are circular. So now I have different line segments. I have squares also. I have circles also which are similar. Can I say that triangles are also similar? Let us look. Let us see that we have these two triangles here. Can I say that they are similar now? So when can I say that they are similar? If they have the same shape. Now do you think that they have the same shape? Let me try moving this a bit and see whether they look of the same shape. It doesn't seem like. I also know that similar objects, if things are similar, that I can decrease the size. Size is not an issue. The shape is the only thing that has to be the same. So let me decrease the size. So I'm not changing the shape, but just the size. And they both still don't look of the same shape. So since the shape is not the same, I can say that they are not similar. So now these two triangles are not similar. So when can I have similar triangles? I know I get similar things when one is the smaller or larger image of the other. So only the difference is difference in size. So what I do is I make such triangles. So I have this triangle here. I make another triangle, a larger triangle than this, such that the shape remains the same. Now in both these triangles, what you can see is that the shape is the same of both these triangles. The outer triangle that is outside is actually larger than the triangle inside. The only difference is the difference in the size. Shape is the same, so I can say that they two are similar. Now I make another triangle which is larger than this triangle also. Again you can see that you can put one inside the other, shape being the same. So the shape of all these three are the same, only difference is the size. Also you can see that the outermost triangle looks like a projection of the innermost triangle. So outermost triangle is also in a way larger or the only difference in the outermost and the innermost triangle is the difference in size. The shape is the same. The size is changing. It has increased in size. So I can say that the innermost triangle and the outermost triangle are also similar. So what we can see is, let me call this as 1, this as 2, and this as 3. I have seen that 1 is similar to 3. 1 was similar to 2. Also, 2 and 3 are similar. Since 3 is nothing but a larger image of this triangle, 2. So 2 and 3 are also similar. Also, what I had seen that the smallest triangle and the largest triangle were also similar. So if 1 is similar to 2 and 2 is similar to 3, what I can say is that 1 is similar to 3. So remember that in similarity, all we are concerned is with the same shape, size can vary. And if 1 is similar to 2 and 2 is similar to 3, then the first and the third are also similar.